Okay, welcome everybody to another Nuts Developer session and tech session this time. We'll be talking about wallets and verifiable credentials for the new upcoming version. A brief agenda. We'll talk about the wallet capabilities and what the Nuts node will turn into, how you issue credentials, which APIs to call, which specifications are supported, standards, revocation, new VC types that are supported, and also some types that are upcoming in new specifications, and a short presentation on what it means that if there are no more NUTS authorization credentials and how you should design your services. Okay, let's start with the wallet capabilities. So this is the general self-sovereign identity diagram, which shows the issuer, holder, and verifier. I added some notes here. I'm showing you this diagram because the NUTS node is turning more and more into a wallet software that can verify presentations, and in a few months or in a month can also issue verifiable credentials using OpenID for VCI. So in the previous and the current version, the NUTS node is actually, well, a NUTS node. It does all kinds of things. It connects to other nodes, it forms a network, and does all other kinds of cool stuff. But it will migrate more toward a more generic wallet with some support for controlling these various parts. I added some tags here in black and some are in red. The black ones are what the wallet, the NUTS node will support or currently supports based on standards. So OpenID for VP is already working. OpenID for VCI is currently in a pull request, but hopefully in a few weeks it will also be in the master branch, so then it's also supported. Both OpenID for VCI and OpenID for VP want a user present. So these protocols mainly go through the browser or are developed with a user and a user wallet in mind. In red, we have the different part which the NUTS node currently supports, and that's the organization wallet. The organization wallet is a construct not supported in those two standards, but if you listen closely to what's happening in the entire world, there is a request for an organization wallet. So maybe we have the first organization cloud wallet already here for the entire world. Who knows? But there's a challenge with this because getting credentials in your organization wallet without users or using your organization wallet without users is not standardized yet. So those are the two red tags there. The S2S flow stands for the service-to-service flow, and side loading means that you can use an API to upload your verifiable credentials, which you have gotten through some other channel. And those are the interactions which the NUTS nodes can do together. You also see that there are some DID web and DID JSON web key tags there. So the verifiable data registry, which previously was also done by the NUTS node, is now simpler because we mainly focus on DID web, which just uses simple HTTPS traffic REST calls to get the DID document. Ideally, JSON web key can resolve itself, so no infrastructure is needed there. We'll continue with the issuance part, because I said previously, there's no standard to issue credentials from one node to the other node. In the current NUTS specification and version 5 and lower, this is done by the NUTS network, which uses gRPC traffic to get a credential from one node to the other node. We're moving towards a piece of software that mainly supports international standards, and for this part, there's no standard yet. So that's makes it a bit difficult to come up with a new standard. And we're very reluctant to do that, but more on that later. So what do you have to do to get a credential from one node to the other is, well, first you have to find the DAD you want to issue to. Then you can just use the issue VC API, which is almost the same as the previous version of that API. But then the big difference is that you have to transport that credential yourself in the functional flow, which means that in the Bolt, or in Dutch, de zorgtoepassing, is responsible for transferring that credential when needed. When it's received by the application at the other end, there's an API to just load the verified credential into your wallet. So that's the side loading part of getting credentials from one node to the other node, or from the issuer to the wallet. Yes. Okay. So here's an example of the API call. It's the same URL as the current issue API. I think the contents is mostly the same, apart from the verification part, but I'll come back to that later. There is a difference in behavior, because when you use a DID web, something else will happen as opposed to when using a DID NUTS, because issuing for DID NUTS uses the network, and for DID web, it can't use the network. So when issuing to a DID, which is a DID web, you just get a credential in response. Nothing is stored or sent over the network. That is the default behavior from version 6 and forward. You might also notice that the DID webs I'm using here in this example have a very curious URL. And we're happy to inform you that we created a NUTS developer image based on the master image, which automatically creates a dev tunnel, which is a Microsoft construct, but you will get a HTTPS endpoint out of the box. So there's no hassle with certificates anymore. You can just start up the image, you get a shortcode for GitHub. You do need a GitHub account, but when you log in, your node will have HTTPS out of the box. For developers, this is a great improvement. Okay, so this is issuing credential. You will get the credential in return. You will have to transfer it to an organization wallet somewhere. And then there's an API, a new API to load the credential. So this is basically an example how to load it. So you basically pass the credential to the specific URL. Apart from the side loading, which currently is needed for the organization wallet, we're also reviewing the OpenID for VC standard. Hades has implemented this, is still in a pull request. I think we're maybe a couple of weeks away from merging it into master. And then we'll support OpenID for VCI, which means that we can fill the organization wallet with help of a user. And if you have seen the mid-scale nuts demo, you see what is happening. So the user will be transported to some kind of portal. There they log in with e-herkenning, for example. Then they will approve issuing of the credential, and the credential will actually be automatically loaded into the organization wallet, which is in the NUTS node. Okay, the current NUTS network also handles revocations. Now there is a new standard. Well, actually, there's a current standard, and there will be a newer one. We don't know when that's happening, but probably in the next few months, which is called Status List 2021. The new version will be called Bitstring Status List version 1.0. This is a mechanism which is pretty efficient, scales well, and is also privacy preserving. And you only have to download a file over HTTPS, which the NUTS node will do for you. So what is happening if you issue a credential? You can pass the with status list 2021 revocation option. By the way, this only works for DLE web. And in the return credential, there will be another object in the JSON object, which is called credential status. It will have an identifier. It will point to a URL, the status list credential field. It will have an index, and the status, purpose, and type are fixed in our case. If you would look at the status list at this URL, you would get something translated, something that looks like this. It's not the exact amount of zeros you would get, but you'll get a binary or a I think it's base 64 encoded, but every bit in this large string represents a single credential that has been issued or might have been issued. You don't know because it's filled with zeros to the end. And if you look closely to this example, there's a 1 at line 4. There's a 4 at line, I don't know, 9, and then there's an F at line 11. So this is hexadecimal, so it would mean that 3 bits are flipped to 1, which means that there are 3 credentials revoked. And the position of those bits corresponds to the status list index, which is part of the credential. Of course, the actual downloaded status list 2021, it doesn't look like this. It will be encoded, and it will also contain a signature from the issuer. So you can actually trust the status list. And that will be the new revocation mechanism. It all works via internet and normal web calls, and the NUTS node will do this for you when validating credentials. To revoke a credential, you could just call delete on the specific API URL, and this is exactly the same as it was. Okay. Next, something on the different verifiable credential types. There's been a bit of a search. The current verifiable credential data model version 1.1 lists 2 different types of verifiable credentials. There's the JSON linked data with linked data proofs, which is the current default we're using, but we currently also support the JSON linked data JSON web token proof. By the way, these strings I use here are not officially defined anywhere, which is also a shortcoming. So the media types for these credentials are a bit, well, dodgy. They're not really defined anywhere. What is happening is that the selective disclosure JSON web token credential type is recommended by the architectural reference framework for EIDAS 2, because selective disclosure is recommended for all presentations. And the official data type for that one is LD plus JSON plus SD JSON web token, which is a mouthful. We have plans to start supporting this type of credential. And the same goes for the new types of credentials that are listed in the verifiable credential data model version 2, which have these media types as defined here. Is this important for you? Well, if you probably use default settings from the NITS node, it probably doesn't bother you because we're going to choose some sane defaults. It's important for the tech behind it, because one of the shortcomings from the current JSON LD proofs is forward compatibility. So you have these different types, and either there is a JSON web token format, which means that regardless of you're using JSON LD or just JSON, the signature will always be based on the actual bytes in the message. But with the linked data proofs, the signature is dependent on the canonicalization scheme that is used, which is also dependent on the linked data context you're using, depending on the canonicalization scheme. So for those new version 2.0 verifiable credentials, they also added JSON canonicalization, which is just alphabetic sorting of your JSON object and then applying a signature to it. That type of canonicalization is forwards compatible, while the RDF canonicalization, which depends on the linked data context, might not be, because you can't change the context anymore. And this is something you see in the current NITS node, which generates warnings. If a credential is published over the network and you can't download the JSON LD context, you get a warning. It's also very hard for us to update the JSON LD context, because if there's anything in there that is going to be used, then nodes of different versions will not recognize those different versions of the context and will not approve the signatures on it. So that's a limitation on the current JSON LD proof verifiable credentials. So we're pretty happy to see that those new types are officially defined. They get a media type, and we can also choose for a canonicalization scheme that's forward compatible, which is pretty important. Also, those JSON LD context warnings that you might now see in your logs will no longer have it, because we're not going to transport credentials over the network anymore, but they will be side-loaded into your NITS node, or you will get them through OpenID for VCI. So if there's anything wrong, it only generates warnings or errors if they are credentials that are concerned to your node. Things that happen to other nodes, you won't get any warnings and errors anymore for those credentials. So it's a bit technical, but the conclusion is it's going in the right direction, and it would be easier for us to support multiple types, but also support JSON LD without having very iffy signatures that can break when we update context. So forwards compatibility is way better in this new version than it's in the current version. Okay, last part. We're looking at time, 20 minutes. Okay. So this is mainly about the NITS authorization connection. Okay. If we look at the current credential usage and how you have to design around it, there's an interaction with just two parties involved, right? So there's a source that has data, and then there's a client that wants to read data or change data at the source. This is currently done with the NITS authorization credentials. But there's also an interaction pattern where a third party is involved, right? So if there's For example, in the Avodag Weekend or Baby Connect, or I think Kickfay as well. There's a third party that determines if two others can access their data or not. So let's start with the two-party verifiable credential usage. What is currently happening with the NUTS authorization credential, and this is a short form, but it's based on the conclusion we had with the multiple vendor working group, is that a source issues a verifiable credential based on already known authorization data, right? So if you look, for example, to the e-overdracht, you already know which specific file resources may be accessed by the other side. And you do this based on two DRDs, a scope, it might be a citizen server number, and some resources. After this credential has been issued, if a client wants to use it, it has to search for these credentials themselves, attach it to the authorization request, and then do the actual request. The source has to validate these verified credentials and then issue an access token based on those credentials. And then the client requests data using the access token. But then, even when you use that access token that's based on the previous known authorization data, the source still has to check every request if it matches that already known authorization data. And if it's a case where there's just two parties involved, why would you issue a credential based on something you have to check at the later stage anyway? You just could say, okay, well, don't issue the credential, just check it the second time. That a NUTS authorization credential is not just issued. It's issued based on, for example, an organization credential, so an organization identifier, which means that at runtime, when you check access to a specific resource, you could just use that organization identifier and then check the same authorization data you have stored somewhere. We also looked in a different way to support multiple vendors in that multiple vendor working group, but lifecycle management for these authorization credentials would be absolutely terrible. It would be way too complicated because you have to take into account that new organizations or new nodes with the same organization identifier go online, others are offline, how do you revoke, all that kind of stuff. It's way more complicated than just checking the authorization data at request time. So this is was one of the conclusions. So if you look at the flow, so that's what we're promoting for version 6 and beyond. If there are no authorization credentials, how would it look? And keep in mind that we're using OpenID for VP for this as well. So what would happen is that a client will send an authorized request. This is a basic OAuth 2 authorized request. And in response to that, the source will request verifiable credentials for the given scope. And this is all done automatically by the NUTS node. The client or the wallet matches the requested verifiable credentials, which probably asks something about the identity, the organization, and the user, and posts the proof using a verifiable presentation to the verifier. Then this verifier will issue the access token, and the client can request data using that access token. Then at runtime, in this case, the source still has to check if the client has access to specific resources against, again, that known authorization data. So that step stays. It should have been there already, giving the NUTS authorization credentials. Most vendors might have hard-coded this, but in the new case, it will be there as well. In the next few weeks or months, we'll probably spend some time on updating the NUTS wiki and providing some architectural overviews how you would implement something like that in your own infrastructure. It relies heavily on the terms policy enforcement point and policy decision point, which are XHTML roles, but it clearly defines where you have to do what and how it is related to the nuts node as well. If you look to a verifiable credential usage with a third party involved, then there's a real valid point in issuing credentials for authorizing a party. What is the case? There's a source and they allow access to data by a client based on trust on a third party. So a third party issues a verified credential. Recommendation would be always make sure it's a short-lived credential, or at least not valid for indefinite. And then that client can use that verifiable credential to get data with the source, right? So this is what's, for example, is used in KICV. There's a third party that issues credentials, which allows clients to do certain queries at different sources. You could also say something like this can be used in Baby Connect, where there's a directing party that says who gets access at which source. In Avond Nacht Weekendzorg, the ANW use case, this is used as well. There's a which they call in Dutch de regisseurfunctie. They get the first call and they determine which employee will go to the client. So they can actually issue credentials which list the specific employee, the specific client, and the specific care organizations. So it's a very narrow credential and they make it valid for only 2 days. And this is a very valid use case for using credentials for authorization purposes. Okay, so given these design cases, if we look at what the consequences are, so some of them have been reasons to determine what is supposed to be done with the NUTS network, and others the other way around. So if you remove NUTS authorization credentials, the number of credentials that are issued between NUTS nodes will greatly be reduced. Probably like maybe just 1% or something. And if you look at verified credentials and wallets, you see that the main usage is to determine certain claims and traits about the holder, which are predominantly about identification and qualifications. And if you look at that that way, the number of verifiable credentials you will own in your wallet will be limited. Well, and with limited, I mean not millions and probably not thousands, and might not even be 100, but less than 100. And if you look at from the technology perspective and databases and network transfer and all that kind of stuff, less than 100 records is like extremely small. This also means that coming up with a new protocol, so nodes can automatically exchange this, gets way less priority. So we know there's a discussion going on in the, let's say, the world. There's also a the Dutch Blockchain Coalition. They should remove their blockchain thingy from their name anyway. They also address this, that hey, we need something for service-to-service interaction using verified credentials. So it's a concern of the world, but there's no protocols yet. And given the way we think you should get credentials into your node or your wallet, that if they're about identification of qualifications, a user should be involved, and there's a protocol for that. And all the other use cases where it's valid to transfer verifiable credentials, they can just be transferred in the functional flow and then side loaded into the wallet. So that's how we currently think about how to deal with credentials and how to get them in your wallet and the different directions the nuts node is taking. Okay, so this was the last slide. This concludes the presentation on the wallet side of the nuts node and a bit about credentials and the credential design.